Continuing. So we've got 3 more examples. So sometimes it doesn't solve or factor easily, and you've got to use something else like an identity. So if you look at this first example, it has cosines and sines, so I'm not going to be able to factor it. And, well, furthermore, they don't factor separately like one of our examples did. So if we use a Pythagorean identity to transform the sine equation or the sine expression into just cosines, I'm not doing anything to the left-hand side. And the right-hand side, I'm going to replace sine squared theta with 1 minus cosine squared theta. And now I'm going to distribute and move everything to the one side and hope that it factors. So 2 minus 2 cosine squared theta. Didn't do anything to the left. Move everything to the left. Doesn't actually matter which side, but that's the side I'm going to move it to. So that gives me 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. That looks quadratic. Yeah. So I think it's going to factor like a quadratic, so I'm going to try. I'm going to set my first term in each factor, 1 to 2 cosine x and 1 to cosine x. That's the only way to multiply and get 2 cosine squared. And then the only way to multiply and get a 1 with the constant terms is if they're both 1s, either both positive or both negative. Since my middle term is positive, they have to be positive. Now let's verify that this works. I do, in fact, get 2 cosine squared. For outside inside, I get 2 cosine theta plus 1 cosine theta, so that's 3 cosine theta, and 1 times 1 is 1. Good, it worked. So now I use the zero product property and set each factor equal to 0. So I'll do this one first. So subtract 1, divide by 2, cosine theta equals negative 1/2. I sort of have a feeling that we did this exact one before. Maybe not. So we got to do it. So draw myself my little reference angle. So cosine is equal to negative 1/2 there and there. So my 2 answers for this one are 2 pi over 3 and 4 pi over 3. And now I'm going to go back and look at my directions, and it says solve between 0 and 2 pi. So that's all of the solutions I get for that. And now I'm going to solve this one. So cosine theta equals negative 1. There's only one place where cosine equals negative 1. You know where it is. Negative pi. Great. And that's it. So we solved that one. All done. So in the next one, I actually made 2 typos in this expression, but I didn't find them until after I printed it. So it should have said secant squared theta, not secant 2 times theta, and there should have been a 2 in front of the tangent. So basically the expression is wrong. And in fact, that one is impossible to solve algebraically. So I mean, it doesn't have a solution, not algebraic. Okay, so we want to solve this one. And I have a secant expression and a tangent expression, so it would be much easier if I only had one type of trig function. So I'm going to use an identity to replace secant squared. So secant squared is the same as tangent squared plus 1. So I replace that. And now, if I rearrange the terms so they look like standard form of a quadratic, maybe I can. Sure looks spectrable to me. So let's try tangent theta times tangent theta. And in order to get a 1, I'm going to need either a plus 1 or a minus 1 in both places. So it's got to be plus to get positive 2 in the middle, so that works. So it's actually the same factor twice. So I only need to solve one expression. So tangent theta equals negative 1. So if you look at your unit circle, tangent is sine over cosine. So it can only equal a negative 1 when the lengths of sine and cosine are the same, but there's a positive and a negative. So that happens in quadrant 2 and in quadrant 4. Oops. It's 2 eyes, right? So over here and over there. So theta could be 3 pi over 4. And theta could also be 7 pi over 4. So those are my own. I'm still in the 0 to 2 pi. So that's all of the solutions. All right, last one. I have sines and cosines, so it's a good bet that I should try to replace cosine with something including just sines. So right away, I'm going to replace cosine squared with 1 minus sine squared theta. And I'm actually going to distribute the 4 while I do that. So distribute the 4, and I get 4 plus 4 sine theta. Move everything to one side. So I'm going to add sine squared theta and subtract 1. So sine squared theta plus 4 sine theta plus 3 equals 0. This looks like it's quadratic and it factors, and it has only sines, so that's nice. And in order to multiply by 3, I need a 1 and a 3. And if I make them both positive, they add up to 4, so this is great. So now I have two expressions, sine theta plus 1 equals 0, and sine theta plus 3 equals 0. So sine theta equals negative 1. So if we think what angle has a sine equal to negative 1? Sometimes the ones in negative 1s have two solutions. Sometimes they have only one going all the way around. Those are special, the ones along the axes. So sine is a height. So the only place the height is negative. The only place the height is negative 1 is down there. So that would be 3 pi over 2. All right, so that's a solution. And then this one, sine theta equals subtract 3. What do you think about that? Exactly. 3 is outside of the range of sine, so this doesn't give us a solution. Something else. So that's my only solution for that equation, and we're done. Phew!